We'll find, they'll probably get it all squared away eventually. Now, are there any questions on any of the assignments before we get started with 6.64? I think so, yes. We finished up yesterday with it. Because 36, you're ending up having to use the quadratic formula. So what we're starting, or what we're doing today is 6.64. This is the last section we're going to cover this year. And incidentally, as y'all can see already, I was working this problem yesterday to make sure they all work and kind of worked out well. And it turns out if this was 13 instead of 303, this one doesn't work. It doesn't have an actual solution. So you're going to need to change this from 13 to 303. Ironically, when I was checking it to see if it worked or not, it didn't. I noticed that it didn't, so I went back and looked at the video for Algebra 2 6.64 from last year. And it started off exactly as I just did. This problem doesn't work as 13. I checked it this morning. You're going to need to change it. So turns out 360, or kind of a year later, I still hadn't changed the note sheet. It is now changed, so it's not going to, I'm not going to have to do this again, hopefully. And it's just because of when we work this through, the number that we get doesn't work in the radical. The number's not big enough for this to work. I could have probably also flipped the inequality sign to greater than and actually gotten, no, it still wouldn't have worked with 13. So we needed to make the number bigger, and I'll point out why here in a little bit. Now with this lesson, before we start this here, we're going to do 2 with exponentials, 2 with e, we're going to do 2 with logs, and then we're actually going to be done for today. So we're only doing 4 problems. And the reason we're looking at this one here is, well, in the exponent we actually have a quadratic. That's kind of the big difference between this one and what we've done earlier. But our overall processes are going to be the same. So what can we do first? We can subtract 3 from both sides, which will tell us that 5e to the x squared plus 4 is less than 300. Yeah. That's why it doesn't work. Now, what can we do next? We can, I will actually show that here, because in the video I also had someone say that from last year we can take ln of both sides. And if we do that, we'd have ln of 5 times e to the x squared plus 4. Well, we have the 5 with it, yes? So to get this to simplify out, I have to rewrite this as ln of 5 plus ln of e to the x squared plus 4. Well, ln of 5 doesn't simplify, but this other one does simplify to x squared plus 4. And here is less than ln of 300. Yes? So we still have ln of 300. Now to get this by itself, we'll need to subtract the ln of 5 from both sides. And if we do that, we get ln of 300 minus ln of 5. Whenever I have 2 of the same logs being subtracted, I can rewrite it as a single log being what? What's inside is being divided, yes? So we have 300 divided by 5. Well, what is 300 divided by 5? 60, yes? So we get there. Okay. So on a whole, these steps aren't too bad. Would y'all agree with that? I mean, it's not too bad. It's a lot of manipulation. It is quite storming out there. Now, instead of applying the natural log at this point, I'm going to divide by 5, which here gives me e to the x squared plus 4, yes? Is less than what?
So the x squared plus 4, that's with the e.
Yes.
Not 5.
No, it's not 5 to the x squared plus 4. It's just the e has it. And this is part of something that is frustrating with mathematics, because here, the next part, we can apply the ln to both sides. And on the left-hand side, that whole exponent moves to the front, and e simplifies out, giving us this here. So what I did in 2 steps here was the equivalent of all this here. Still get to the same answer, but one of them is a lot harder than the other. Or not harder, just a ton more steps. What do we need to do next? Subtract 4. Now, it's been a while if y'all have done square roots and inequalities. Because here, obviously, x squared, to get x by itself, we need to take the square root of both sides. So if I take the square root of x squared is x is less than the square root of ln of 60 minus 4. But what have we always done when we took the square root of both sides? We added something in, the plus or minus. Because whenever we square something, it could be positive or negative or what we're squaring. So I'm not going to just specifically put it over there. I'm going to rewrite, because we could also have the negative square root of ln of 60 minus 4. And when we had equations, when it was just an equal sign, it really didn't matter, because it's either going to equal the positive or negative version. But with inequalities, x is either less than the positive version or x is greater than the negative. So when we do the plus or minus with inequalities, we have to change the sign for the negative version. Essentially, we divided both sides by a negative, or multiplied both sides by a negative. So we get these 2 cases here. Part of the reason, or I'll go into that here in a minute. So if we want an exact answer, we could say that negative square root of the natural log of 60 minus 4 is less than x is less than the square root of the natural log of 60 minus 4. This is the exact answer. Because the natural log is not going to give us a number. That should be fine. Yeah, so we would need it in both cases, because the negative needs to have its own sign. Or we can do the approximate answer. Did you have it? Or if not, I can plug it in. Or I didn't know if you were saying that you had what that is. .307. All we do is change the sign, same number, as we get this here. And this here is our answer. Now, obviously at the start, we changed it from 13 to 303, yes? Well, if it was 13, when we minus 3, it would have taken it to 10. Divided by 5 would take it to 2. So if we'd have left it as 13, this would have been a 2 and this would have been a 2. Well, the natural log of 2 minus 4, what's we get this here. We get a negative. But it's inside of a radical. Can we take the square root of a negative number? No, so there is no answer for this. That's why it didn't work. Does that make sense? Essentially, this number, or what we were saying before we squared it, is that x squared is less than negative 3.306. Whenever we square a number, it's always positive. So there's no way I can square a number and get less than a negative. So this just doesn't work out right. So the reason I put 303 is because I needed to pick a number that when plugged in to the natural log gave me a number bigger than 4. So that we ended up with a positive and it works. Kind of makes sense. Stuff that y'all won't ever have to think about on any of this here. Any questions on this here? The only real kind of tricky part or step was remembering to do this. Otherwise, it's the exact same as what we did yesterday, yeah? Or the day before. Any questions on any of this here? Let's look at this one. What would we do first? Subtract 5. It tells us that e to the negative x is greater than 9. Then what? Natural log of both sides. So ln of e to the negative x is greater than ln of 9. Then we would end up, we can divide by negative 1. We can multiply by negative 1. But we're wanting positive x is less than negative ln of 9. And then at that point, if we want to figure out what the approximate answer is, we can plug that into a calculator and it'll tell us. There's not a whole big deal. Negative 2.147. Is that what you got? For the test coming up next week, give me both. Give me both. The reason I say to give me both is, one, I will, when grading it, this is the first thing I'm going to be looking at is what you get as the approximate answer. If that doesn't match up with what I've got, the next thing I'm going to look at is this here. Because if that is the correct answer, that it is x is less than negative ln of 9, but for some reason this one didn't match, I'm still going to give you full points because that just means from here to here is just calculator. So something in the calculator, for some reason the graphing calculators act a little funky every now and then because somebody found out they can do or tweak something deep in the code or deep in the program, going into menu, change one thing, and for some reason it's messing everything up. Or just a calculation error, you type a negative instead of a subtraction or something small. Because if this is right, calculator error, I'm not going to mess with that at this point in the year. You'll still get full points. That way you have both. But it's still good to give me this. Because I mean, at most, it's just typing a few buttons in the calculator, hitting enter, and you're done. And especially on the evaluation part, whenever it says evaluate the log, I want it as a decimal. If it is a decimal, if it's a whole number, that's fine too. We'll do 2 logs, so we'll do this one here, and then I'll let you pick out of the last few which one we want to do. Now for this one here, I really need another set of parentheses. That 3 is attached to the 2x minus 3. It's not attached to the log itself. Now the first thing we can do here is what? move the 3 up front. Because anytime we have a power inside the log, we can move it to the front. Telling us that we have 3 times the natural log of 2x minus 3 is greater than 6. What can we do next? Divide by 3. Anything divided by itself is 1. What would we do next? Because if it was e, then yes. But since we're starting out with the natural log, we need to put both sides to a base. So we put both sides to the base of e. Because e to the ln, gone. Just leaving us with 2x minus 3 is greater than e squared. What's next? Add 3. And last but not least, divide both sides by 2, and x is greater than e squared. Like how I wrote that, 2 e squared plus 3 all over 2. We do have some restrictions because we're talking about this variable being inside the log, yes? Now for most cases, when we end up with x being greater than it, it's most likely not going to need this. But if we went on and solved this, adding 3, so 2x is greater than 3, dividing by 2, so x has to be greater than 3 halves. So all the values of x that work for this here have to be greater than 3 halves. Is e squared plus 3 over 2 greater than 3 halves?
Yes.
Because what are we adding to the numerator? So e squared plus 3 has to be greater than 3. And it's 5 point something. So it is bigger. Yep. So does it matter that x has to be greater than 3 halves? No, because x is already going to be greater than 3 halves. That's our answer. Because it's only when those restrictions come into play that we need them. Because if it had said x is less than this, okay, we would have to add in the fact that x has to be greater than 3 halves. Any other questions on these here? All right, we'll look at one more. Which one of these do y'all want to look at? This one here? Okay. Now there's different ways that we can do this one here. So we do have one log on one side and a number on the other, yes? So what's the first thing we could do? Use our base, which is, we can put both sides to the 10th power. Because these will cancel out, telling us 8x to the 4th is greater than 10 to the 24th. What can we do next? Divide both sides by 8, which tells us x to the 4th is greater than 10 to the 24th over 8. What would we do next? It's not square root, it's 4th, because if we have a 4th power, we need to take a 4th root. And the 4th root of x to the 4th is x is greater than, see here, 8, so 24, so this would be 10 to the 6th square root of, no, so it's not square roots, 4th root of 2 over 2. And there is a simplification we need to do technically with the 10 to the 6th and 2, but it's a little, because 10 to the 6th, 3, 4, 5, 6 is 1 million. So really what we're saying is that x is greater than 2, 1, 2, 3, 500,000 times the 4th root of 2. I know I jumped around there. Let me back up. So we're taking the 4th root of 8, yes? Well, 8 I can rewrite as 2 to a power, because 2 to what power is 8? To the 3rd. Now the numerator, I can rewrite 4th root as a fractional exponent. The reason I'm doing that is because 24 will divide by 4, yes? What is 24 divided by 4? 6. So, okay, that makes sense where 10 to the 6 came from, yes? Can I simplify the 4th root of 2 to the 3rd? Well, no. 3 does not divide by 4 evenly. What's the next number that does? Well, 4, yes? To get there, I need to multiply the denominator by the 4th root of 2, because if I multiply it by the 4th root of 2, we do get the 4th root of 2 to the 4th, which simplifies to 2. But what do I do to the numerator? Denominator I also have to do to the I just thought through these way too long, so I can do some of those jumps. But as we saw already, 10 to the 6th is 1 million, and we're dividing it by 2, which just tells us that x is greater than 500,000 times the 4th root of 2. Questions on this so far? You're not going to get something like this on the test. We could, yes. But we also have because again, if we take an even root, we have the positive and negative case. So it works with 4th roots as well. We do have this or statement. Now again, what's inside the log cannot be negative, yes? But if we look back up here, our negative number is being typed into x to the 4th. Any even power is going to turn that negative into a positive. So we actually do get this or statement. Questions on this here? Well, that's it for this here. So your last homework assignment of the year is this right here, 47 through 52 all.